This example of ray or vector reflection is based on trigonometry. It's addressed based on the requirement to know coordinates of the source position of the ray and direction in which it's going. Also length of the ray, so we don't perform calculations indefinitely. And we need to know two coordinates for every reflective surface. So the reflection angle itself found with the following calculations. First we find intersection point between surface and the ray. And once we find it, based on the law of cosines, we can determine angle, incident angle, which is alpha on this picture. And we know that normal to the surface always at 90 degrees. So if we know incident level, then we can calculate this angle between normal, the ray, beta. Now, based on the Pythagorean theorem, we know the length of hypotenuse and the angle, and this angle would be 90 degrees, so it's a right triangle. So based on the Pythagorean theorem, we can find the length of this cathetus. Now, if we have this right triangle, and we'll have another one exactly like this on the other side, we will have our reflective angle. And since we can determine the length of the cathetus, we know specifically that this direction would be on the length of two cathetuses. But this is just a length. To find specific coordinates, we need to use this vector, which is the surface we reflected off. So we calculate unit vector for this surface, and then multiply it by the length of two cathetuses, and we receive our coordinates. Now these calculations will be performed recursively, first for the source position and direction, and then this would become source position and this would become direction, until the length of the ray is 0. Now in the code there is nothing interesting, it's just functions. I use one auxiliary class, which is called segment, to store intersections, determine if there are any, and to store surfaces coordinates. This requires some attention, that while I'm calculating intersection, I'm using math approximately function, because sometimes even if float numbers looks exactly the same, they are not, so this is important. And in the presentation I have 4 segments, which would be like outer walls of which ray would be reflecting, and 5 walls of this object with 5 sides. I'm using polygon collider just to determine points. It's only used for the points. But these are actually 5 logical segments. P0 would be source of the ray, and P1 would be its direction. So let's see it. And you see it's reflected. And if I move it, it's actually building quite nice. So that's it. You can download this script under the video. Thanks for watching.